All right, guys. So we got last application in this chapter, the center of mass and moments. So what we're doing here is we got a wire, and that wire goes from A to B on the x-axis. And then what this function does is it's the density function. So it's telling us how dense this thing is. And so for this particular function, the further we go out from the origin, this one gets more and more and more and more dense. Okay, I'm exaggerating. It's infinitesimally thin because that's the way that these problems go. But the density is getting more. It's getting more and more and more dense the further out we go, just because these numbers get bigger the further we get from zero. So that's kind of the visual, and because it's variable density, the fulcrum that would balance it. You know, if you think about something like a rod, and on one end it's not that dense, but the other end it's very dense. You know, if I want to try to balance this in the middle, that's not going to work. This is going to weigh down more because of the density. So the fulcrum would have to be moved over to where it would balance out. So the mass and the density kind of balance around the fulcrum, based on the density, I should say. So anyway, that's what this function is. It's a density function. So the center of mass is going to be this calculation down here, but the mass itself is given by this. It's the integral of the density. So this is the density function times the x differential, all right, over our interval. So obviously this is A and this is B, the way that they've got it set up. So for part one, I need that because I'm going to put that in the denominator, right? That's the center of mass. We divide by the mass. And then it's basically like a weighted average. You know, these are the numbers in the interval from A to B. You know, these are the x's that are in there. And we're multiplying them by the density at that value. And then we are dividing by the density. So you can think of it, what's left is like x. This is very, very similar to the weighted average formula. If you've ever done a weighted average, like a grade average, you know, something like that. All right, so let's do the calculation. So the first thing we need to be able to do is multiply this by x. Okay, we're going to multiply that by x for the calculation for the center of mass. So that's going to be x times 3 will be 3x plus another x here would be 5x to the fifth. All right, that's going to be part of our numerator. All right, so this is in two parts. Part one is find the mass. So we're going to integrate between -4 and 4 of the original function. So 3 plus 5x to the fourth dx. Okay, so this is going to be 3x plus integrating, I'll get x to the fifth over 5 times this 5 will just be x to the fifth. All right, and now I'm plugging in 4, I'm plugging in -4. When I plug in 4, I'll get 3 times 4 plus 4 to the fifth power. All right, and then I'm subtracting, but watch what happens. Minus 3 times -4, right, and then minus -4 to the fifth. And in both cases, it's minus a negative, so it ends up being positive. 4 to the fifth is 1,024. Minus a minus would be plus another 12. Minus a minus would be minus negative 1,024, so that'll be plus another 1,024. So all that ends up being 2,072. All right, so that's the mass. That's also the denominator in this calculation. So I will integrate now from -4 to 4. I go up 1. So again, 3x plus 5x to the fifth dx. Now when I integrate this, I'll get 3x squared over 2, so 3 halves x squared plus, this will be x to the 6 over 6, so 5, 6x to the 6th. And I'm plugging in 4 and -4. Now this time, because these are squares, even powers, the sign doesn't change. So these would all just cancel. Everything's just going to cancel, and it's just going to give us a 0. So what we end up with is 0. This is 2,072, but it doesn't matter because we get 0. And the reason that we're getting that is because we're trying to find the center of mass. And over this interval, we're going to get something that has the same, it's symmetric at 0. Because 5x to the 4th plus 3, well, that's just going to look like this. You know, with that's bottoming out at 3 on the y-axis. There's a negative 4, there's 4. And so the density is symmetric to the left and to the right. So as we move to this way, you know, the density goes up in the same amount it goes this way. So it's the exact same amount of density at opposite numbers in here. And so it balances out. It's going to give us a center mass of 0 on the x-axis. Let's put in here to check it. 2072 is what I got for my mass, and then my center of mass, I got 0.